Okay, imagine this. Just yesterday, right? A brand new AI model drops. And this thing, it can apparently write, debug, and even deploy whole software applications autonomously.
Hmm.
And here's the real kicker. It's totally free, open source. We've spent ages talking about will AI replace programmers, but, well, this release from Alibaba, it kind of feels like the future just showed up. Now,
It certainly makes you stop and think, doesn't it?
it really does. So welcome back to the deep dive, everyone. If you're a developer, maybe a tech enthusiast, or honestly, just someone fascinated by how fast AI is moving, well, today's deep dive is probably going to challenge some of your ideas about what's possible right now.
Yeah, we're really peeling back the layers today.
We are. We're looking at Qwen3-Coder. That's Alibaba's latest AI model. And look, this isn't just another coding helper, not like the ones we've gotten used to.
No, definitely not.
We're talking potentially an autonomous software engineer. So our mission for you today is to figure out what makes Qwen3-Coder different. Different from, say, GitHub Copilot or even something advanced like Claude.
Right. What's the real step change here?
Exactly. And why is the open source part such a big deal? And, why might this be a really, really important AI release, even if it's not plastering all the headlines? We've got some pretty wild benchmarks to talk about, and we'll get into what this could mean for programming careers.
It's a lot to unpack.
It is. Let's start with just the scale of this thing, Qwen3-Coder,
Hmm.
because the numbers alone are, well, they're pretty astounding.
Mm-hmm.
We're talking 480 billion parameters. Now, okay, that's maybe smaller than some giants like GPT-4, but the real cleverness, as I understand it, is how they're doing it, this mixture of experts thing.
Yes, the MOE architecture, that's key.
So what does that actually mean for performance, but also maybe for who can actually use this?
Look, well, the MOE, mixture of experts, it's genuinely a game changer for these huge models.
Mhm.
So instead of firing up all 480 billion parameters every single time you ask it something.
Which sounds incredibly resource intensive.
Exactly. Hugely intensive. The MOE approach lets the model be smarter. It only activates a small fraction, maybe around 35 billion parameters for Qwen3 coders that are most relevant to that specific query.
Okay.
Think of it like a massive library full of specialists. You don't need every single specialist to answer one question, right? You just go to the right department.
I see.
So it drastically cuts down the computation needed for each answer, but it still has access to that enormous overall knowledge base. It's just way more efficient than a traditional dense model of the same size.
Okay, so it's like having this enormous brain, but one that's really good at focusing just the right parts, conserving energy. That feels like a pretty fundamental shift in, how we might deploy these big AI models.
It really is. It tackles that scaling problem head on.
And that scale, that efficiency, it leads to something else you flagged, which is this context length. Native 256,000 tokens, extendable up to 1 million. Help us visualize that. Tokens are roughly words, right? What does 1 million token memory mean in practice?
Yeah, roughly. Think maybe 3/4 of a word on average. But 1 million tokens for developers. That's
Yeah.
monumental. It means the AI can literally hold an entire medium-sized code base, maybe even larger in its active memory, all at once.
Wow.
So imagine you're asking it about a change. It doesn't just see the lines you touched. It sees the whole project.
The history, the dependencies.
Everything. The history, the dependencies, the architectural choices made months ago, how different parts interact across maybe hundreds, thousands of files.
Mhm.
It's not just suggesting code anymore.
Right.
It's understanding the entire context, the design patterns you've used, maybe even predicting side effects of a change somewhere else. It's a huge leap in comprehension, a much more sort of holistic view.
Okay, that's genuinely impressive. Now,
Yeah.
how did they train something this capable? Because the method sounds pretty revolutionary, too. They talk about a scalable system running 20,000 independent environments in parallel. 20,000.
Yeah.
It sounds like they built this, I don't know, virtual army of coding sandboxes where the AI could just practice and learn constantly.
That's a pretty good analogy, actually. It's not just about feeding it more data. It's about giving it a massive space to experiment.
Right.
They trained it on, what was it, 7.5 trillion tokens?
Yeah.
And a huge chunk of that, 70%, was code. That's like reading all of GitHub many times over.
Oh, okay.
But the key is coupling that data with the ability to try things out in those 20,000 environments.
Hmm.
Getting real-time feedback,
Yeah.
failing, learning, iterating simultaneously across thousands of scenarios.
So it's not just reading the textbook, it's doing thousands of homework problems at once.
Exactly.
Yeah.
It's active problem solving at a scale we can barely comprehend. It's much closer to how humans learn through trial and error, just massively accelerated and parallelized. It suggests future AIs will be schooled through experience, not just data dumps.
Leading to much more robust systems, presumably.
That's the idea.
Okay, and then there's the competitive angle. Alibaba's benchmarks claim it performs comparably to Claude Sonnet 4. Now, anyone who's used Claude for coding knows that's a serious claim.
It is. Claude is very capable.
So is it really neck and neck? Or are there areas where, Claude still clearly wins out?
Well, based on the published benchmarks, it seems very competitive on general coding tasks. Of course, real-world use often shows up subtle differences. Claude is a commercial product, closed source.
Right, so maybe more polished edges, specific enterprise features, perhaps?
Possibly. More curated guardrails, maybe specific optimizations. But the headline fact is that Qwen3-Coder gets close to that level of performance, and it's Apache 2.0 licensed. Meaning completely free. You can download it, run it yourself, modify it, assuming you have the hardware, which we'll get to. But that combination, free and competitive, that's the real disruptive part here. It changes the whole landscape.
Yeah, that value proposition is hard to ignore. Okay, let's shift gears a bit. We've mentioned this model being potentially an autonomous software engineer. Let's talk about agentic AI. What does that actually mean? It's more than just fancy autocomplete, right?
Oh, much more. Agentic implies the AI can operate with a degree of autonomy, can understand a goal, create a plan to achieve it, execute that plan step by step, monitor its own progress, debug issues it encounters, and iterate until the goal is met, all without needing constant hand-holding.
Okay, so break that down practically. How is that different from, say, GitHub Copilot? Or even Claude, which is pretty interactive?
Right, so Copilot is mostly reactive. You type, it suggests the next few lines or maybe a function block. Claude is more conversational, more powerful. You can ask it to write larger pieces, explain concepts, refactor things, but you're still largely guiding it. You provide the prompts, the steps.
You're the driver.
You're the driver. With an agentic AI like Qwen3-Coder aims to be, you could give it a much higher level goal. Something like, build me a REST API for a task management system. Make sure it has user authentication using JWT.
Okay, a typical project brief.
Exactly. And the idea is it then goes off and does it. It figures out the architecture, maybe chooses a framework, writes the Python or Node.js code, defines the database models, implements the login and registration logic, writes unit tests, handles common errors.
Wow. So it's like giving the brief to a senior dev and checking back later.
That's the concept, yes. A significant jump in autonomy.
Is there a concrete example of this?
Yeah, they had one in their documentation that really stood out. A developer asked for a complex sorting algorithm but with specific optimization constraints.
Okay.
Instead of just dumping code, Qwen3-Coder apparently analyzed the request, came up with 3 different algorithmic approaches, actually explained the pros and cons, the trade-offs of each.
Like a real design discussion.
Exactly. Then it recommended the best one for the constraints, implemented that one, wrote tests to prove it worked correctly, and even provided performance benchmarks for its own code.
That's not just coding, that's engineering. Thinking, analyzing, validating.
Precisely. It shows that deeper level of understanding and self-sufficient execution that marks a potential step change.
Incredible. But does all this amazing capability live in its own little world, or does it actually plug into how developers work today? You mentioned a CLI.
Right. The Qwen Code CLI command line interface. That's a key part of making it usable. They've clearly thought about integration.
So it works with existing tools?
Yes. The CLI is designed to work well within terminals, hook into IDEs like VS Code, integrate with common workflows like Git and GitHub Actions. They even mention compatibility with tooling built for Claude, which is interesting.
Ah, smart. So they're not trying to force everyone onto a whole new platform.
No, the goal seems to be supercharging existing setups, making developers more powerful where they already are.
And what are the early users saying? You mentioned compelling feedback.
The reports coming out from early adopters are pretty striking. People are saying it writes code that follows established best practices, includes decent documentation automatically, and this is crucial. It often catches edge cases or potential issues that maybe a more junior developer might overlook. The phrase that keeps coming up is something like, it's like having a senior engineer pair programming with you 24/7, not just suggesting, but actively contributing, building alongside you.
Okay, that sounds amazing. But
Yeah.
is it really human-level discernment? Or are we still talking about sophisticated pattern matching that might generate subtle bugs, things only a human would spot? What about hallucinations?
That's the million-dollar question, isn't it? And the honest answer is no AI is perfect. There's absolutely still a risk of subtle errors, logical flaws, or those confident-sounding hallucinations.
Right.
So human oversight doesn't go away. It just changes focus. Instead of hunting for syntax errors or typos, maybe you're reviewing the AI's architectural choices, verifying the core logic, testing its assumptions. You
Yeah.
become more of an auditor, a director, a quality control lead.
That makes sense. So let's turn this to you, the listener. If you're coding day to day, how would an AI like this, working with this much autonomy, actually change your job? Does that prospect excite you? Or maybe does it make you a bit uneasy?
It's definitely something to mull over,
Yeah.
and leads us right into the practicalities, because here's the elephant in the room.
Yes. The hardware.
Exactly. Despite being open source, running that full-fat 480 billion parameter model, that takes serious iron. Industrial-grade stuff.
Like multiple top-end GPUs, loads of memory.
Yep, multiple high-end GPUs. We're talking NVIDIA H100s or similar, hundreds of gigs of VRAM.
Yeah.
It's data center level hardware, far beyond what most individual developers or even smaller companies have sitting around.
I saw someone online put it bluntly. Consumer GPUs can't handle the 480B model.
Hmm.
Use cloud services or wait for smaller variants, which perfectly captures this open source paradox. Right?
Yeah, that's a great term for it. The code itself is free, open, available. But the means to run it effectively, the computational power, that's expensive. You could easily be looking at hundreds, maybe thousands of dollars a month in cloud compute cost to really leverage the big model.
Which definitely challenges the whole idea of democratization. If only those with deep pockets can actually run the most powerful open source tools, is it really open in a practical sense?
It's a critical question for the future of AI development. What does open mean when the barrier isn't code access, but compute access?
But Alibaba anticipated this, didn't they? You mentioned their architecture allows for smaller versions.
Exactly. That mixture of experts design wasn't just for efficiency, it also makes it easier to scale down. They've released smaller variants alongside the big one.
Okay.
For instance, there's a 30 billion parameter version, still large, but because of MoE, it only uses about 3 billion active parameters per query.
Which is much more manageable.
Much more manageable. Still needs decent hardware, probably a good GPU, but it puts it within reach for more individuals, researchers, smaller teams running it locally, or on more affordable cloud instances. It's not as powerful as the 480B monster, obviously,
Right.
but reports suggest it's still very competitive with other models in its weight class.
It kind of reminds me of computing history, doesn't it? Early mainframes filled rooms only for governments or huge corporations.
Right.
Then came the PC, putting power on desks. Then cloud computing lets startups access massive infrastructure without owning it. Maybe AI is following a similar path. The cutting edge needs huge resources, but useful versions trickle down.
It does feel like a similar pattern might be emerging. The absolute state-of-the-art is expensive, but capable, accessible versions follow.
So what do you think? Is having these powerful models available via the cloud good enough for democratization? Or do we really need them running efficiently on, everyday laptops before innovation truly explodes everywhere?
It's a debate for sure. Cloud access lowers the barrier significantly compared to buying the hardware, but it's still a cost. True on-device power would be another level entirely.
Which brings us to maybe the biggest question of all, the one everyone asks. What happens to programmers if AI can program?
Right, the existential question.
What's your take? Is it replacement or something else?
My conviction. It's transformation, not replacement. Think about how IDE's integrated development environments change things.
Sure. Autocomplete, debuggers, refactoring tools.
Exactly. They didn't get rid of programmers. They made them vastly more productive by handling the tedious stuff, catching simple errors. Agentic AI, like Qwen3-Coder, feels like the next big step on that path. It's like, going from a manual screwdriver to a power drill, or maybe even to a CNC machine. The nature of the work changes.
So less time on the nuts and bolts, more time on the big picture.
I think so. Instead of spending hours writing boilerplate code, fixing syntax errors, or digging through API docs, developers might shift their energy much higher up the stack.
Towards what specifically?
Towards things like complex system architecture, designing really intuitive user experiences, deeply understanding the business logic and goals, and, crucially, learning how to effectively direct and manage these AI agents.
Oh, okay. Like the construction foreman analogy you used earlier, they don't lay every brick, but they know the whole plan, coordinate everything, ensure quality.
Precisely. They understand the blueprint, manage the specialists, human or AI, solve the tricky integration problems, make the high-level decisions. It becomes less about typing code, more about orchestrating intelligence to build the right thing.
Of course, it's not all smooth sailing. There must be challenges, real concerns here.
Absolutely. We have to be honest about those. People raise valid points about the quality of AI-generated code. Can it be trusted? Is it secure?
Yeah, security feels like a big one. Can it introduce subtle vulnerabilities?
That's a risk.
Yeah.
And maintainability, what's it like working with a huge code base, mostly written by AI? And maybe the most important one, how do new developers learn?
Right. If the AI writes all the basic stuff, how do juniors build that foundational understanding? How do they practice debugging, learn algorithms if they're not doing it from scratch?
The learning path will definitely have to evolve. It's a serious consideration.
So maybe the skills needed are changing too. Less raw coding ability, more AI whispering.
You can put it that way. Skills like understanding AI output critically, becoming really good at prompt engineering, crafting clear, effective instructions for the AI, and providing that crucial human oversight and quality control, those might become more valuable than just banging out lines of code.
We're already seeing reports from teams using these advanced tools, right? Productivity boosts.
Yeah, early reports often mention significant productivity gains, sometimes 40%, 50%, even 60% for certain tasks. But, and this is the vital part, they almost always emphasize that human oversight, architectural vision, and critical thinking become more important, not less.
Interesting. So the AI handles the volume, but the human guides the direction and ensures the quality.
You're not just coding anymore, you're conducting an orchestra of tools and intelligence.
So wrapping this part up, it feels like the question isn't if this tech changes programming, but how fast we adapt. Adapting to a world where maybe the main bottleneck isn't how fast you can type, but how well you can define the problem and design the solution.
That seems to be where we're heading. The bottleneck shifts from execution speed to problem definition and system design.
All right, let's try and bring this all together. What's the bottom line on Qwen3-Coder?
Well, I think it's fair to say it represents a really significant leap in AI coding. It's open source, which is huge. It's clearly very powerful based on the benchmarks and capabilities, and it's out there now.
Even with the hardware caveats for the biggest version.
Even with those caveats, the fact that this level of AI is freely available, even in its smaller forms, is going to put immense pressure on the commercial players. It's bound to accelerate innovation across the board.
So what's the call to action for listeners, especially developers?
Start experimenting. Now, don't wait. Whether it's with Qwen3-Coder's smaller versions, or Claude, or Copilot, or whatever comes next week, get your hands dirty.
It's not about avoiding it then.
No, I don't think you can or should. The key is learning how to work with these tools effectively, how to integrate them, leverage them, make them a multiplier for your own skills. It's about augmenting human intelligence, not replacing it.
A powerful perspective.
The future really seems to be about collaboration between human developers and AI agents.
You know, the release of Qwen3-Coder, it might just be one of those moments we look back on. Maybe not because it's the perfect final version of anything, but because it feels like AI crossing a threshold, moving from just being an assistant to potentially being an autonomous agent right in the heart of something as complex as software engineering.
A turning point, potentially.
Yeah, a moment that really pushes us to rethink what it means to create, to build software. So until next time, keep building, keep learning, and maybe remember that thought. The future might belong to those who learn how to conduct the orchestra, not just play one instrument.